Yeah, thank you very much. Yeah, I'm a student of Stadio Institution. And my name is Ezomo Odion Taiwo with the student number 242-33062. The module name is Teaching Practice B and the module code is VTPB172. Yeah, I'm actually doing a presentation on a topic, differentiation from first principle. Yeah, there are actually a lot of differentiation. There's differentiation by chain rule, by product rule, there's differentiation by quotient rule, and there's differentiation by first principle. But the one I want to talk about here is actually on differentiation for first principle. Um, yeah, the first slide is talking about what is differentiation. So let's quickly go uh, and talk about differentiation as a topic. Yeah, differentiation just means figuring out how fast a function changes. How the function is changing is what we call differentiation. Then it's actually about finding the derivative of a function. Example, when you are asked to find the derivative of 2x, the answer is 2. So it is a derivative. Then it's actually about the derivative shows the slope of a line tangent to the curve at a point. So those are the three main explanation of differentiation as a name. Then quickly, let's see the next slide in which we will talk about differentiation for first principle. Now, the derivative of f of x at a point x just means how f of x changes around that point. Yeah, we actually need a particular formula to solve differentiation by first principle. This is the formula we need. F prime is equals to limit h tend to 0 f of x plus h minus f of x divided by h. So this use the idea of limit to find the slope at x. And it is simplest way to define derivative. So first principle can be in form of three stages, three forms. The algebra function, the quotient function, quotient with two linear expression, which is quotient functions, then trigonometric function. These three topics can be solved by first principle. So we're actually going to touch all of them with one or two examples. So let's go to the next slide and see. Now, there are major steps in which is it involved when you talk about differentiation for first principle. The first step is step with the function f of x, then in which you compute. So anywhere you see x, you put f of x, x plus h. Anywhere you see x, you put x plus h. Then from the difference quotient, f prime is equals to, this is the formula we use, f of x plus h minus f of x divided by what? H. When h tend to what? Is 0. Then simplify the expression. Simplify the expression. Then the last one, you now say take the limit as h tend to what? H tend to is 0. So these are the major steps in which you follow when you are doing differentiation from first principle. Now quickly, let's quickly go to the very first example. Yeah, this is the first example we want to talk about. The question is f of x is equals to x squared. Now the question will now tell you differentiate from first principle. There are two ways of solving this particular question. You have to go according to the instruction. If the question say just find the derivative, you can just differentiate and you say f of x, then you are fine, you will not be penalized. But if the question tells you that use first principle, in which I'm talking about, you have to use first principle, unless if you use any other method, you will be penalized. Now example f of x is x squared. Like I told you, anywhere you see x, you put x plus h. That's why we have x plus h here. Then this is the square we are talking about. You will expand it. After the expansion, you have x squared plus 2xh plus h squared. This steps 2. You now go to f of x plus h minus f of x. So that's why you have the expanded one here, minus the f of x is the question you have on top, which is this one here, minus f of x. Then you have 2x plus h squared. Then the step 3, you have to now divide everything by h. That's why you have the h here. So you divide everything by h. When you divide by h, you have 2x plus h. Then step 4, that's the last step, in which you say the limit. That's the one I showed you initially under the formula, that h tend to what? H tend to 0. So 2x is equals to 0. So the final answer is what? 2x. So therefore, when you use differentiation for first principle, your final answer is what? 2x. This is the first example. It's an algebra example. Let's go to the second example. The second example. The second example, we talk about the slide f of x is equals to 1 plus h. 1 plus h. So after this very example, what do? You have f of x plus h is equals to 1 over x plus h. Yeah, there's another one. I think I've skipped it, but I will try and go back. But this is example 3. Then we now have a step 2, f of x plus h minus f of x. So when you have f of x plus h minus f of x, it will now be 1 over anywhere you see x. Like I told you, it will be x plus h. Then minus the f of x, which is the question you have here, which is minus 1 over x. After you finalize it, you solve it using the LCM method, then you have your h minus x plus h all over x plus h plus x into bracket x plus h, in which you simplify that, you have minus h all over x into bracket x plus h. Then the third one is now the division we talk about, in which you apply the h. You divide by h. So when you divide by h, your answer will be minus all over x into bracket x plus h. Now the last one is now the one you will do what? You will now say h tend to 0. So when you apply h tend to 0, this h will now become a 0. H tend to 0, this h will now become. So the final answer is minus 1 over x squared. So that is the answer for this very example. Let's look at another example. Another example now, we are talking about the trigonometric function. The trigonometric function is actually in two ways. It is either you differentiate sin x or you differentiate cos x. When you differentiate sin x, you get cos x. And when you differentiate cos x, you get negative sin x. But this particular question, we are actually using first principle. That's what the example is talking about, and the presentation is all about. Now, when you apply first principle here, you see your f of x is equals to your step 1, f of x is equals to cos. That's the question. Then you apply what we call compound angle formula. The compound angle formula here you apply is going to be cos A plus cos B minus sin A multiplied by sin B. That's the formula we apply here, but we have to change the A and B to x plus h. That is how you have to. That's why we have cos x, cos h minus sin x, sin h, because it is the f of x one. After you have expanded this one, the third one is this formula you're supposed to apply. But after the formula here, you need to subtract minus f of x. That's why you have your cos x here, and you now put it everything all over h. When you apply cos x here, you factorize. When you factorize, you will get cos cos x cos h minus cos x. After factorization, it will be cos into bracket cos h minus 1. Then there is a particular identity applicable, because the the space is actually limited. That's why I'm just trying to explain out of what I wrote here. So you see there's an identity given here which is limit x tend to 0. So when cos h minus 1 also tend to what? Is tend to what? It is tend to uh, is 0. It tend to 0. While the other one sin h over sin h over h also tend to 1 because it's an identity actually. So in that case, wherever you see cos h minus 1, which is this one here, that's cos x multiplied by 0. Why this one is sin h over h is 10 to 1. That's why you see 1 here multiplied by sin x. So the final answer here will be negative sin x. So when you differentiate cos x, you're actually going to get negative sin x. So let's go to the next one, which is the quotient rule, the quotient expression of linear that I'm talking about. We can also use first principle. So for us to differentiate this one by first principle, this is the question. F of x, that's 2x plus 1 all over x plus 2. This is the question. The same principle is applied there. X plus h. Anywhere you see x, you put x. That's why you have a x plus h here plus 1 all over x plus h plus 3. In that case, you now expand it. That's why 2x plus h plus 1 all over x plus h plus 3. Now, you now apply the second step. You minus f of x. So all these ones you have here minus the f of x. The f of x is the question, 2x plus 1 over x plus 3. You solve this one by simplification. After solving it by simplification, you arrive at expand the simplified numeric, which is the one on top. You simplify it as well. After filling the simplification, you get your answer here. You now move to the f of x plus h, in which you are supposed to divide everything by what? By h. That is the one you have here, this particular one here. Divide through by h. After you have divided through by h, you will get your f5 on top. Then this one here must be a twin factor. That's why we have x plus h all square. We have x plus h all square. So in that case, our final answer, because you have set h tend to 0, anywhere you see all the h, they have tend to 0 already, so they have no use. So this one is 5 over x plus h all square. So therefore the final answer is 5 all over x plus h all square. So I have actually talked about the first principle of the tree method, the algebraic, first principle from algebra, first principle from trigonometry, and first principle from quotient. Then the last this one is actually the summary of the rule. From the work example, we can generalize this rule. The power rule, which is xn raised to power n minus 1, that one is applicable to power rule. It's also from algebra. Then we have the reciprocal rule is also here. This is the formula. Then the trigonometric rule is also applicable, in which it is sin x, a differentiation of sin x, which is cos x I talk about. And the last one is the quotient linear function, which is this one. So these are the rules where all proving directly using by first principle. Thank you very much. Thank you very much. Thank you very much.